All right, 7th graders, scientific notation, lesson 4.9. When you're converting numbers to scientific notation, you're starting with the number written in digit form, like this, 8,600,000, and converting it to a number that is written as a power of 10. So it's taking this number and writing it as 8.6 times 10 to the 6th power. And if you multiplied this out, you took that number and multiplied it, or put it in your calculator, wrote equals, you would get this number. These two numbers are equal. Okay? It's just a different form of writing the number. That's what scientific notation means. And it's used for writing really big numbers and really small numbers. Okay? Rather than writing out 10 to the 23rd power, so a 1 with 23 zeros behind it, they use scientific notation and write it as 10 to the 23rd power. Or 1 times 10 to the 23rd power. Or really small numbers, like the weight of an atom, something that's really, really small. And so that's converted to scientific notation also. But when it's a really, really small number, it's used with a negative exponent. Okay? So take a look at this example. 42 10,000ths. The way that you write any number in a scientific notation is you start by writing this first number, so 8.6 or 4.2, and both of these are between 1 and 10. So the decimal point goes after the first digit in this number. Okay, everybody with me so far? The decimal point goes right after this first digit. Okay? And then you write all the non-zero digits, all the numbers that are non-zeros. So the decimal point goes here, and we write the 6. Or in this case, the decimal point goes into right behind the 4, and you write 4.2. So whatever the non-zero digits are, you put the decimal point in after the first digit and write all the other digits that are not zero digits. Okay? Then you count the places after that first place. And in this case, there are 6 of them. 1, 2, 3, 4, 5, 6. And so we know that this number times 10 to the 6th power are equal. 8.6 times 10 to the 6th power is equal to 8,600,000. We use the 6 because there are 6 places behind the decimal point. Okay? Does that make sense? You with me? 6 places behind the first digit, so we use 10 to the 6th power. Alright? If there are 3 places in a small number, since we put the decimal point behind the 4, if there were 3 places up to the original decimal point, then we would use -3. That's how you write and find a negative power. The decimal point was right here in the original number, and we moved it to the right 3 places to convert it to scientific notation, and so we use 10 to the -3rd power. Okay? Does that make sense? Nod your head if you're with me. Does that make sense? Okay. Now, what if you had to multiply 2 numbers? That's something you have to do on the test. Is you have to multiply 2 numbers that are in scientific notation. Well, it's kind of like multiplying the numbers when they had the same base. Multiplying powers when you have the same base. If we look back at our notes, what you do is you add the exponents. Carson, seriously. You can't stop playing with this? You add the exponents when the numbers have the same base, and these are in base 10. So you would add the exponents to get the new exponent in your answer. Okay? And to find the answer to the other one, you just multiply the numbers. So, if you're multiplying 1.6 times 10 to the 6th power times 3.7 times 10 to the 4th power, then you would multiply the two numbers, these two numbers, 1.6 times 3.7, and get this answer. And then it's 10 to the 10th power, because 6 plus 4 is 10. The two exponents are 6 and 4. And when you multiply exponents with the same base, the base is 10. When you multiply them with the same base, you add them together and get the answer. Okay? So this is 5.92 times 10 to the 10th power. Does that make sense?
Yeah.
All right. Now, one more thing. What if, when you multiply these, what if it was 1.6 times 37? What if it was 1.6 times 37? Your answer would be 59.2 instead of 5.92 times 10 to the 10th power. But is this in scientific notation, you guys? What's wrong with this in scientific notation? Why isn't it in scientific notation? Brett?
Because
Read this.
the decimal isn't in the right place.
Yeah, the decimal point isn't in the right place, or the first number is not between 1 and 10. 59.2 is way bigger than a number between 1 and 10, right? So we'd have to move the number, or the decimal point, this way one place in order to put it in scientific notation. But we can't keep the exponent in the same power then, because the decimal point is over one more. It's not over 10 places, it's over 11 places. So we'd have to write this as 10 to the 11th power. Alright? We'd have to multiply it by a bigger power of 10. So anytime you're converting something like this, and you have to move it another place, one more place, you change the exponent by 1. Okay? Just keep that in mind. And that first number, when you write this out, has to be between 1 and 10. Okay? Alright. Let's go through some of your assignment. How much did you...
We did 1 through 4.
Just did 1 through 4?
And 1 through 15 at the back.
Okay. So, do you know what a million is as a power of 10? 10 to the 6th power, yep. So if we start with that, then this is 745 times 10 to the 6th power, but we have to change it to 7.45, which means we'd have to move the decimal place 2 more places to the left. We just talked about that. If you have to move the decimal place 2 more places to the left, what does that equal then? It's not 10 to the 6th power, it'd be 10 to the 8th power. Good. Now, as you're correcting this, remember your classwork, you're graded on taking notes, but you're also graded on correcting with a pen. So make sure everybody's correcting with a pen. Where's your assignment? All right. Correcting with a pen, and making corrections in pen. So not just marking it wrong, but I'm going to be checking you for your classwork to make sure that you are on the right place. And then making corrections in pen. Okay? Cool.
I forgot to put multiplication
Times 10.
Yeah.
All right,
I
then
just
that
put
should
them
be,
next to each other.
yep. But that looks like
Yeah, I know.
7.4510 then. So put a big multiplication sign in there.
Or can I put parentheses?
No, it's usually, I've never seen it written in with parentheses. I've only seen it with an X, and I know X,
They use a dot.
don't usually that. Yeah, you can put a big dot there. I would accept a dot, that's
Okay.
actually better. How about this one? In this case, we're going to be getting a really small number into scientific notation. So that means our exponent is going to be positive or negative? Negative, yep. Ariana? Yes. Okay. Now, how many places does it go to get behind the first digit? 4 places, good. So it's times 10 to the negative 4th power. How about this one? Starting with a really big number. This is 8.882. Those are the non-zero digits.
Oh, so you put all the
So
numbers.
you put all of the non-zero digits.
Okay. 'cause
Up
it's
until it
kind of-
starts to be just zeros. Okay? And then it's times 10. And we've got 3, 6, 8th power again. Yep. I'm sure that that's a little and again, make your corrections in pen. Okay? Just make your corrections in pen. The last one, 5.7 times 10.
To the third
There's
power.
3 places to the 3rd power. All right? What's number 5? You recognize that one at all?
Oh yeah.
Yeah, what is that? Exactly, it's the one we did in our notes. So what would we do?
5.9.
Describe the procedure. What would you do with multiplying 2 numbers? Max?
Well, you would add the two digits.
Yep, you would add the exponents. So this is going to be 10 to the 10th power. But how do you get the first number? Remember, I underlined these. Then what? Come on, people, think. Do you add when you're multiplying these? Come on, what would you do? What are we doing with these two? You're multiplying, so you would multiply. Yes. 1.6 times 3.7. And what is that? Do you remember?
5.9.
Good. 5.92 times 10, because the base is 10, to the 10th power because it's 6th power plus 4th power. Okay? How about this one? Let's do this one without your calculator. Can you do 3 times 2?
No.
You better be able to. 6 times 10 to the, and you add the exponents. So it's negative 4 plus negative 5, which is, yeah, this is not complicated. Okay? Now, how do we do this? 7 72,000 times 143,000. You know what, we can do this without too much work either. This is 10 to the 4th power. This is 10 to the 5th power. So, what's 10 to the 4th plus 5th?
10 to the 9th.
10 to the 9th. Very good. Now, if we write this as 7.2 times 1.43, we can also get the digits just by putting in 7.2 times 1.43 into your calculator. What's 7.2 times 1.43 in your calculator? Type it in. 10.
10.296.
Okay, 10.296. Then move the decimal place over one more place. And that's going to change it from 10 to the 9th to 10 to the 10th. This is the reason I'm going through this, you guys, is this is on the test. Okay, this is going to be on your test. You need to know how to do this. So, we change it to, the answer is 1.0296 times 10 to the 10th power. Okay? Alright, let's go to the back side. Standard notation. So if it's 10 to the 4th power, that means there would be 4 places behind the decimal point. 3, 7, 7, 0, 0, right? And then put the commas in. Write the digits out, and then you have to have commas, yes. You have to have commas. Can you round them? Yes. Yep. Yep, you have to have commas in. When they're really small numbers, so this has to be 3 places past the decimal point. 8, 5, 0, 0. This one has to be 5 places. Oops, other way. This is negative. So this has to be 9. So this is 1, 2, 3, 4, 5. And then 0, 0, 2. So this is 3, 4, 5. Because it's 10 to the negative 5th power. You have to move it 5 places over. Now, one of the things that might be helpful to you when you're doing this is to just make these little skips. So it's 1, and then 2, 3, 4, 5. And then you can see there'd be 4 zeros in front of the 9. It might be easier for you to get the zeros in the right place.
Wait, there are 4 zeros in front of
4 zeros in front of the 9 because the 9 counts as one of the places that you're moving it. No, it's not 5 because it's negative 5th power. Yes. So in front of the decimal point, there is another 0. 0.00009. Yep. And then again, 1, 2, 3. So there's 2 zeros in front of the 1. Okay? We've already done these. So we're going to go on to the chapter review. Any questions on scientific notation? Any others that you want me to go through with you?
Not him.
All right.
Cody.
A butterfly.